Lo conก่อน
Vero.
Good afternoon, students. How are you doing today?
Good afternoon, sir. Not too bad.
I saw your message today, right?
Yes, sir.
I saw your message. I'll soon respond to you.
Okay, sir.
Okay.
And did you check about the McLaren series and worksheet?
No, but what I'm going to do is I want to the volume of rotation shouldn't be that bad because you all know how to integrate. It's just for me to show you the ropes of the rotation about the x-axis, y-axis. So what I want to do is to see if we can find some past papers. And I know Tariq sent some and Arno sent some in the group. And we're going to go through and we're going to find questions on the past paper. Each of you can share a past paper. It don't have to be me alone. And I'm going to tackle some past paper questions. So I think that is good enough. What it is that we need to do is to work as many past papers so we can see how CCCJ pitches their questions. So in the meantime, I give you just a few and waste, 5 o'clock and people are just getting out of work on the way home and the whole work. So I give you a couple of minutes to just cool off a little for today only, and then we hit the ball running. See if we can find the papers, Alwyn, and then we each of us can just project and we just work on one question or two question, and then get back to our stuff. All right.
All right, sir.
All right, I'm back with you. Does anyone want to share? Pick on fast. We'll just select one question from the first person to share, and we get the rest of the lesson from here. Please and thanks.
Sir?
Please.
Sir, I'm not sure what the instruction was before, but I didn't hear it.
So the question was asked about additional questions. So I'm saying what we could do instead of going into a textbook, we could peruse the past papers and we could project a question or two from the past papers on areas that we've already covered. And we could spend a little bit of time and just run through one or two of those questions before we continue to our volume calculation.
Okay, sir.
But I'm not going to belabor the point there now because I'm asking if you find something to share, please. I'm going to give you another 2 minutes. There's lots to do, places to go, people to see, things to do.
Yeah, the corner here on the chat.
It again?
Yeah, I was saying the corner. Send one in the chat.
Oh, sorry. Thank you. Thank you, Colonel. Then Colonel, you couldn't oh gosh, you just start off the one you play rough. All right. No problem. Before I do that one though, Colonel, I would love if we could go through the whoa, 10 marks. That's not 10 marks. How much is that? 10 arcs? Um, before we do that one though, I'd love if we could I'd prefer if you do the homework one first, before we get into that one. All right. Noted. I'm seeing that one and noted again, Colonel. Were you just finding all of them with the 135E? Not a problem though.
What homework when you're talking about, sir?
Did I not? Oh God, hard. Help me out. Did I send you anything regarding the question that we did in class the other day?
Yes, sir. A
Colonel, that's
question
it.
was on the bottom of the worksheet.
But I mean, I like when some of stop sending questions for no. Because it means that you get the stuff and don't look at it. Some of you that is. Yes, man. Come on, man. All right, start working on that. Let us just focus on working on that one for me, please. 10 minutes, 10 minutes, 10 minutes, 10 minutes. 10 marks on each question. I'll give you 10 minutes for it, you know. Amoy,
Yes, sir.
I've not heard from you since evening.
I'm here, sir.
Did you do the homework, Amoy?
No, sir. Doing it.
Remember the left knee today?
Yes, sir.
Okay, all right. We're not saying nothing more to you here. We don't
Yes, sir.
talk. We don't talk. All right. So as you work on that, I want you to just hear me out here. Some of you did very well for Cal 1. And again, I am at this late stage still going to congratulate you. Some of you barely made it for Cal 1. And you too, I'm going to congratulate. But what I'm seeing is a general trend with the class. I'm not getting the energy from some of you. The energy is just not there. Real talk. Real talk. I don't know if it is that you have external competition, work, family, whatever else, other personal issues, but I'm not getting the energy from some of you. And what I'm worried about is if you allow the Cal 2 to run away with you, you're going to be in problems. And I don't want that to happen. All right? I could have come today and said, okay, we're continuing, but I'm pivoting to go back a little to give enough of you time to catch up. So please, something was sent in your WhatsApp following Monday's class. I want you to go through it as best as possible and kind of found 2 additional questions that we need to pay attention to. So another 8 minutes. Thank you.
Sir.
Yeah, man.
Yes, sir. Pointing out, my electricity went, so I'm on my data and it's not picking up so well. So if I'm not participating, that's why.
All right. I have been recipient of that on Saturday. My Cal 1 class just never went the way I wanted it. And it happened to me on Monday again. So I'm fully aware of that. I think they're having some problems with JPS and the internet system. Just do the best you can. If needs be, you can just message me so I
Yes, sir.
can. Cool. All right, cool.
Okay, sir.
I'll reset the chat. Alvin, hearing me?
Yes, sir. We're hearing you.
Yeah, I'm trying to get Alvin's attention, but I think he did say that his internet is kind of in and out. All right.
Yes,
Are you
sir.
back? You hear me?
I hear about your.
Right. I was saying to you, check the chat. Check the chat. Please. Yes. No, don't
You're
talk, Alvin.
breaking up.
No, you're breaking up, Alvin. So just talk to me through the chat. Just respond to my message, please. You're breaking up. All right, guys. Has anyone else completed the answer for that one?
Sir,
The homework question? Yes, please. Somebody said, sir.
sir, sir,
Mhm.
you hearing me now?
You're choppy. I hear that you're speaking, but you're choppy. I think we lost him.
Sir, yeah, you hear me now, sir?
Yeah. Loud and clear. Go ahead. Say it again,
Sir,
Papa. Uh-huh.
yeah, yeah. Me
I'm saying,
recently, but me get
I'm
keyboard
saying,
type a while ago.
okay. Repost the answer for me, please.
Okay, sir.
Cool. If any one of you um has completed the homework question, can you just post your answer for me, please? And just need to see where it is that you are, and if it is that you're on the right track, so I can be informed of where I need to take the lesson. And kind of give us 2 questions, we need to do it.
Okay, sir. I resend it.
All right, checking. All right. I'm responding to a few answers. Some correct, some not so correct. Person taking a second chance. We need to hear from the rest of you. Come, guys, come. Guys, 5:46. I'm giving you 4 more minutes at 5:50. I need to know. And guess what? If you don't give me an answer, don't think that I'm going to come and do it and say, oh, sir, soon do it. I've already responded to those students who have spoken to me, and I'll only deal with them. You must do your homework. This was homework from Monday. All right? So I'm not going to come and project an answer there. Hmm, 2 more minutes. All right. Clearly, I need to go through this one. So I'm going to get my writing tablet. All right. Yeah, it's a struggle.
Sir, I got kicked off, sir. I just sent you something in the chat.
Come on, I saw it. Can somebody read a question for me, please?
There it says the graph
Go ahead.
of y equal x squared plus x minus 1. Is that right?
Say it again.
So the graph of y equal x squared plus x minus 1
Hold on there. These two. Graph of y equal x squared.
plus x minus 1
Mm-hmm.
between x equal -1 and x equal 2
Mm-hmm.
is rotated completely around the x-axis. Find the volume generated.
Tell me if you agree with that.
Yes, sir.
What about the rest of you?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
X squared times x squared is x to the fourth. X squared times x is x cubed. X squared times -1 is negative x squared. X times x cubed. X times x squared is x cubed. X times x is x squared. X times -1 is negative x. -1 times x squared is negative x squared. -1 times x is negative x. And -1 times -1 is a positive 1. X to the fourth plus 2x cubed. This one cancel with that one, so I'm going to have negative x squared minus 2x plus 1. Tell me that's what the graph of y squared.
Yes, sir.
Yes, sir.
Thanks, Carrie. Thanks,
Yes, sir, I got that.
Good job.
No.
All right. Look and see what I have and see if you agree with me.
I messed up here, sir.
Oh, my one messed up, sir. No, my one wrong. Sorry.
You see the mistake?
I look for it now.
Sir,
Looking
I
for
see my mistake.
All right, good job. All right, that's important to know. Important that we can see where we went from. All right, so continue working with me now. So for those of you who made a mistake, just watch me. Those of you who got it, are on the right track so far, follow me until you can see where it is that we went wrong. So now it is that I'm going to be integrating pi, Lord Jesus, what was this again? 2 - 1. X to the fourth plus 2x squared minus x squared minus 2x plus 1 dx. That now becomes x to the fifth over 5, 2x to the fourth over 2, x cubed over 3 minus 2x squared over 2 plus x.
Sir, would it be 2x to the fourth over 2 or 2x to the fourth over 4?
2x to the fourth over 4. Everything else is correct?
Yes, sir.
Good job. If I want, I can simplify. And then now I'm going to have, remember, it's the upper limit minus the lower limit. This is pi into 2 to the fifth over 5 plus 2 to the fourth over 2 minus 2 to the third over 3 minus 2 squared plus 2 minus negative 1 to the fifth over 5 plus negative 1 to the fourth over 2 minus negative 1 cubed over 3 minus negative 1 squares plus negative 1. Agreed?
yes, sir.
Yes, sir.
So this is pi. 2 to the fifth is 32.
Yes, sir.
32 over 5. 2 to the fourth is 16.
Yes, sir.
2 to the third is 8 minus 4 plus 2. That's a negative number, so that's negative 1/5. It's a positive power. So this is going to become a half. Negative 1 to the third is negative 1, and negative 1 to the negative 1 is a positive 1/3. Negative 1 squared is a positive 1. Positive 1 times negative 1 is a negative 1. Plus times a negative is a negative 1. All right, so I'm not going to get creative. I'm simply just going to be using my calculator. 32 over 2 plus 16 over 2 minus 8 over 3 minus 4 plus 2 is equal to 58. over 3. At this stage, I'm not going to get creative. I'm showing an LCM. This is big school maths. Put it in a calculator and work it. Negative 1/5 plus a half plus a third minus 1 minus 1. Negative 41 over 30. So this is now 58 over 3 plus 41 over 30. How creative can I get? If I multiply the denominator there by 10, I'll get 30 and 30, so that means the LCM here is going to be 30. 580 plus 41. 580 plus 41 is how much? 621. Um, 621 divided by 30. It's 207 over 10. Is my first term correct? I think something went wrong with my.
So the first one is incorrect, sir. The 58 over 3. No, I get that, sir.
Yeah, no, let me ask you.
That wrong.
Yes, so take time and tell me now. You talk so strong.
I
Sir,
want to put it wrong, sir. Come and say that.
Yeah, but
Yeah.
we still a talk. It still a talk strong. Minus 8 over 3. Minus. So when you get something wrong, make sure 146 over 15. No, either something that.
Yes, sir. Yes, sir.
146 over 15. So my LCM is still 30. 146. 146 times 2. It's 292 plus 41. 333. It's going to be 111. 111 over 10. Uh, that's going to be 11 and 1/10. 5. Agreed?
Yes, sir.
Those of you who didn't get it. Are you seeing it now?
Yes, sir. That's up at the top part. That's what I mean. I messed up. But that's
Yes,
all for it.
sir.
Which part? The part that is supposed to be doing the multiplication?
Yes, sir.
Same where it's squared.
All right. I'm going to ask this question. Take it or leave it. Is there anyone in the class not understanding what I just did a while ago? This is not between you and your classmates. It's between me and you.
Can I scroll back a little bit, sir?
Sure. I'm actually, as we speak, replaying what I had typed in my calculator. I saw. I saw. I saw. Now, the mistake that I made earlier, instead of putting 32 over 5, I put 32 over 2, 16 over 2 minus 8 over 3 minus 4 plus 2. I had everything is correct. Away from that, 5 is supposed to be 32 over 5. I had 32 over 2. And that I got 58 over 3. And I'm saying to you guys, I'm human, and I know you are too. Mistakes are there to be made. Just double check your answer. That's what I keep saying. Turn the calculator off, turn it back on. This is big school. Type everything into the calculator. What I didn't do was to read back on my calculator. I just went ahead and just do the calculation, quick and fast. Read back what you have on your calculator to make sure that you're punching the correct terms or values. It's going to hurt you. And I really don't want that to happen. All right, any other question?
Sir, Monsieur, what was my mistake? In the question that you're working, last 0, we never really did that. I think so just minus the lower limit from the entire thing rather than plug it into the function.
Or you just put minus 0.
Yes, sir.
Yeah, man.
Yeah, but otherwise, sir, global.
Got you. And thanks for your honesty, Alvin. And I'm hoping that the rest of you will learn from our mistakes. And I said our because I put 32 over 2 instead of putting it over 5 and got 58 over 3. So the more you minimize, I mean, I'd have picked up quite a bit of mark for the question. If there's a 10 marker, I'd have picked up about 7 marks out of the 10. So I would I wouldn't have failed the question, but I just want to get full marks. Let me ask you. Are we better off now or
So I can scroll up a little bit more.
waiting on you to tell me whether or not I can go?
Yes, sir, you can go.
Yes, sir.
Right then.
All right, good. Um, all right. Um, hmm. Let us do let us do um a question that is let us do a question that is rotated, not a full 360. Let us try. Carlo, I switched devices. Oh dear. I switched devices, so Carlo, I am not seeing those two questions you originally posted. Can you just repost those two questions for me, please? Thank you. All right. The first one that was just reposted. Let us give an attempt. Don't worry about the what is it? If I can find it. Don't worry about the 135 just yet. Go ahead and see if you can do that question for me.
Which question, sir?
There's a question that Connor just posted in the chat.
Oh, okay. Let's see. All right. So yesterday you should know about what, sir?
Don't worry about the 125 just yet.
Okay. So do everything as normal.
Mhm.
Okay.
hoping that you are now working. Um, 5 more minutes. How is the? Hmm.
Sir, I'm stuck one part.
You stuck where?
No, I'm stuck.
Stuck
Where?
where?
In the
Solve
square.
X first.
Solve for X? What do you mean by solve for X? I don't
Sir,
understand that.
sir, when you square the y, I get stuck.
All right, so let's rotate about the x-axis. There's some things that we need to look for. We need to know where it's rotated x-axis. So the integral be a pi y squared dx. Do you agree with that formulation?
Yes, sir.
Good. Which is now going to be upper limit is
1.
lower limit is 0.
Yeah.
Function is
2 over 3x plus 1
2 over 3x plus 1. That's it?
squared.
Ordered. Good job.
Sir.
Squared. Right. Something is still missing from this, but I'll tell you. I'll tell you. I just want to work this one here. I'm going to tell you, and then we can compare an answer. But as I come start this stuff here again. All right. So one of the things that we need to do is to find y squared. 2 over 3x plus 1 times 2 over 3x plus 1. Agreed? Yes, no, maybe so.
Yes, sir. Yes, sir.
Yes, sir.
All right. That is now going to be 4 over 3x plus 1 all squared, which is 4 over 3 is 9, man x squared plus 3x plus 3x plus 1.
Yeah, no, so that me not do my things, me not do madness.
Well, question says supposed to square this up to 6x plus 1.
Yes,
So y
sir.
squared is y squared is equals to all of that. Now, we need to go ahead and what your paper was this, Colonel? You have an idea?
I've got checkbook, sir. 1 second.
All right, cool. So now the question says y is equal to all of that. And it's been rotated about the x-axis. So it's going to be y squared dx. So I need to square y. And in squaring y, I'm going to get 3 is 9x squared plus 6x
August
plus 1.
2017.
2019,
2017.
2017, long time paper. So let's go. How do we integrate that now? Any ideas?
So me do same. Me do the same thing. Add 1 to the exponent of a top over, which is 9x cube over 3 plus 6x squared over 2 plus x. And then they can simplify, which they go down to 3x cubed plus 3x squared plus x. So the final thing would have be 4 over 3x cubed plus 3x squared plus x. When I substitute the 1, would have go down to 4 over 7.
I disagree.
I disagree. Okay.
Yeah, because this one here now is 4 over 9x squared. It's not the other way around. So the reason I ask you what year it is, there are different methods for integration. And what this works out to be now, let me show you, is the integral of this basically is a substitution. This basically is a substitution.
Yeah, that's
I did
the one from there, sir.
substitute what?
The one.
Which one?
The upper limit.
No, I want to substitute. I mean, I have to integrate first before I substitute. Remember?
Yes, sir. All right.
Right. So what if I say, let u be equals to 3x plus 1 all squares. I'm going to find du by dx. It's going to be 2 times 3x plus 1 to the first times 3. So du by dx is going to be equals to 6 times 3x plus 1. And all of that is over 1. And across multiply, I'm going to have du to be equals to 6 times 3x plus 1 dx. And then divide both sides by 6. Sorry. And divide both sides by 3x plus 1. All of this cancels that. So therefore, dx is going to be equal to du over 6 times 3x plus 1. Look at that and tell me if you agree, please. Just look at the differentiation and tell me if you agree with that.
Yes, sir.
Are we okay with what I have there? Do you agree? Is there a miscalculation on my part, or is it okay?
You look good to me, sir.
Like chip in and chip out just so something like that.
Mhm.
Get the understanding of what you did.
Yeah, so what I did, I recognize I have this to integrate. So I'm going to be integrating via the substitution method.
Okay.
Mhm.
So let it stay as 3x plus
Right,
1 squared, which
right.
was the original before.
Mhm.
Oh, and then you work it from there instead
Mhm.
of doing the 9x squared plus 6x plus 1. Oh, okay.
Um,
Because it,
it would still be the same thing. Tarek, let me just show you. Because if I were to differentiate this, I'm going to get 18x plus 6 talk truth.
yes, sir.
And 6 is common, so if I factor out the 6, I'm going to get 3x plus 1 down.
Oh, okay. I see.
Yeah, man. So it's just a method of integration, sorry, differentiation.
Yes, sir.
It's called a power rule.
From calculus 1.
So right, so whichever of the methods I use, if I differentiated the 9x squared plus 6x plus 1, I still end up with the 6 times 3x plus 1. And if I use
Yes.
the power rule, I get the same thing. Right? So because I'm using the substitution method, I'm making a substitution for u. So it means that everything now has to change.
Oh, okay.
It's a total change in the question. Nothing that was given before can be used. I have to go fix up, right? But guess what? We have a fix up for dx because dx is now going to be equals to du over 6 times 3x plus 1. Everybody see that?
Yeah.
Mm-hmm. Now, I'm going back to the question. X equals 0 and x equals 1. X equals 0, x equals 1. So what I'm doing is I'm letting u to be equal to 3x plus 1 all squared. But if I'm going to do that for x equals 0. What did they say to me? X equals 0 and x equals 1. So I'm going to make it for x equals 0. So that's work with me. X equals 0. So u is going to be equal to 3 times 0 plus 1 all squared. What is 3 times 0?
0.
0.
And what is 0 plus 1 all squared?
1.
1. So when x is equal to 0, I'm going to have u equals 1. watch this similarly. U equals 3x plus 1 all square for x equals 1, was it?
Yes, sir.
Yes,
For
sir.
x equals, right. So u now is going to be equals to 3 times 1 plus 1 all square. What is 3 times 1?
3,
And what is 3 plus 1?
4,
And what is 4 squares?
16.
16.
So what I'm saying to you now is that is going to be my new lower limit, and it's going to be my new upper limit. What I'm saying to you is, I can't go ahead and do the integration if I'm making a substitution. If I'm making a substitution for u, I can't have 4 over u dx because I can't be integrating a function in u with respect to x. That will make it. So everything I forgot to know in u. Remember now, my upper limit and my lower limit, these values are x values. Sir, how you know? All right, we go check. See here, x equals 0, x equals 1. We can't do the integration with respect to you and a man in a different jersey. We can't have that. They're not upon my team. So I have to make that substitution. Is there any other substitution that I must make now? Talk to me now, man. Look like I have everything there set out. All right, since you don't talk to me, let me just go on to my.
Yes, sir.
Let me go on.
We have upper limit and lower limit. So.
Yeah. All right, I was trying to. How do I do this quick and fast? Never mind. Never mind, I can see it from here. I lost my thread of thought. Okay, get it back. So, so let me pause here. You see the importance of us working past paper questions? Because you may say, sir, we never did do this. I actually did. We did substitution in calculus 1. And that's why calculus 1 is a prerequisite for this course. Because now we have to go back to calculus 1 in order to do the integration by substitution. Right? So it's very, very, very important that we work past paper questions. Don't come to class without the past papers. All right, let's go. So now I'm going to write the integral, and I'm going to write 16 up here, so, and 1 down there, so. Tell me if you agree with that, and tell me why I do that.
Because 16 is the new upper limit and 1 is the new lower limit based on where to just calculate.
Very
That's
good.
what I get.
Very good. So I'm going to have a new lower limit and a new upper limit, for which I have to do. Say it again.
It was done.
Oh, the audio was down. Okay, no, my team wanted to chat, so I was plugging it in. So I have now a new upper limit, and that upper limit now is going to be in U. So what I now need to do is to write my 4. And what I'm going to do is to write this as 3x plus 1 all squared. Tell me if you would agree with me with that. Is it the same thing as 9x squared plus 6x plus 1?
Yes, sir.
Yes, sir.
I mean that for ease of calculation. Remember, d of x now, I have to make a substitution for d of x as well, don't? So d of x is going to be du times du over hold on. Calculation is right, but it's not what I thought I was going to get for my answer. Upper limit is right. 3 plus 1 whole squares. All right. So let me tell you where my headspace is going. So as I work the question, I'm expecting where the question is supposed to be taking me, but as I'm calculating, it's not taking me there. 3x plus 1, okay, that's 0. So that's going to be 1. And x equals 1. 3 times 1 is 3. 3 plus 1 is 4. 4 squares is 16. Good. And if I allow that to be, oh, okay. 1 over 3x squared, 3x plus 1 squared, dx. I'm going to have du over, checking that differentiation, 2 times 3x plus 1. Oh, but I did check it, I get the same thing there. So du times 1 is du, right? So if I flip it, I can have d of x, du is equals to 6 times 3x plus 1 dx. I want to make dx a subject, so I divide both sides like that. So du is really 6 over, no, du is going to be equals to, yeah, it's du over 6 times 3x plus 1. All right. All of these are coming into, this is not helping me. I'm going to tell you where I thought I was going to go. The question is correct. I mean, the working out is correct. I thought I was going to have my du up top so that I can do my cancellation. So I was hoping that the 3x plus 1 will be in the numerator, and then I can cancel one of those from the denominator. And I don't like where this one is going. Me no like how you look. All right. Here's another method that we can use. This one is not taking us to where I want to go. I'm gonna go back and look at the question here. Find the volume of the solid when region is bounded by the curve that, the line that, and it is rotated 135. Okay, that part is fine. This is actually looking worse than what we had it before, because I'm going to end up now with 3x plus 1 to the third power. And it is better for me to have 4 over 3x plus 1 to the second power, as opposed to getting now 2/3 or 2 over 3x plus 1. Let me just write it what I have there instead of saying it 16/1. 2 into that goes 2, 2 into that goes 3. 2 over 3x plus 1 now to the third power du. That looks uglier than what I had before. Yes, I know I can factor out. The other method that I'm going to do it and send it off to you tonight, because I just recognize when it's minutes to 7. What I can do, I can take out this 4 and I can factor out the 4. Method 2. I can take out the 4 and I can factor it out. 4x, 4 over 3x, 4 over 3x plus 1 all squared, 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 dx, 1, 0. And of course, this is pi. I can take this out, that 4, because it's a constant, so I can have 4 pi, the integral of 1, 0, 1 over 3x plus 1 all squared, dx. And then I can, when I integrate 1 over a function, what do I get? When I integrate 1 over function, anybody remember when I integrate 1 over function, what I get? Quick and fast. I will finish off the question for you, but just tell me, when I integrate 1 over function, what do I get? Anybody remember? Trust me, when I come quick and fast, let's get stuff in. Talk to me now, man. When I'm integrating 1 over a function.
ln. I don't know. So take out
Excellent. I'm
ln.
gonna get right. But but is that function though? When do I get ln? I get ln when it is what? Hmm?
Exponential. No, not sure.
All right. No. All right.
1 over the
All right. So let me.
the 1 over the function is multiplied by the function.
Multiply by the what?
multiply the square.
Multiplied by, is it the differentiation of the function?
Very good. You see,
differentiation of
you're working very hard. But keep it up. But you are correct. Are you? No, you're not seeing it. Let me just share something quick and fast. So Taj just gave you the correct answer. So what I'm saying to you is, when we're integrating a function that is 1 over if it is 1 over x, if it is x to the negative 1 or 1 over x to the negative 1 or 1 over x to the first power, then we use the natural logarithm, the ln function. The ln function. And I'm just refreshing the memory here, the ln function. If, however, we're integrating and we have 1 over like x squared, what we can do, we can recall this negative, we can carry this now to x to the negative 2. Can you see that? I'm integrating 1 over x squared. So what I'm doing, I'm rewriting the function, remember, recalling the use of the integral, 1 over a to the positive m is going to be equals to a to the negative m. So what I'll do is to carry whatsoever is in it. Once I have a 1 up here, that's why I'm factoring out the 4. So once I factor out the 4, I'm going to have a 1 in the numerator. So what is going to happen to me now is that I'm going to say x to the now the negative 2, because I'm taking everything now into the numerator. So this becomes x to the negative 2. X to the negative 2, it does not become a logarithmic function or ln function because it is not negative 1. If it were negative 1, then we talk about the ln function. That's the only time we talk about the ln function. It is negative 1. All right? So we can go ahead, add 1 to the power divided by the new power. So what it is we're doing, we're adding 1 to negative 2. We're going to get negative 1 divided by negative 1. Does that refresh your memory at any point in time? Hello, somebody quick and fast,
No,
please.
sir, I never remember about this. But, okay.
You don't, but oh well, it's been a while that you did this. But yeah, man. So
Mm.
if it is -1, x to the -1, I'll show you x to the -1, which is the same thing as 1 over x. Then we're going to talk about the ln function, right? But if it is not -1, we'll have to integrate otherwise. So let me just show you what it is that we can do. I have a class thereafter. So let me just show you what we're going to do. So we're going to call this 4 pi, the integral 1, 0, 3x plus 1 now to the -2 dx. And then now we're going to recall this. 1 over a to the m is going to be equal to a to the -m. And then we add 1 to the power and divide by the new power. So we're going to be adding 1 to all of that. And then we have to multiply by the differential of the inside and reciprocate it. So it's going to be 4 pi, 1, 0. We're adding 1 to the power because I'm integrating. I'm not going to write that sign again. So it's 4 pi 3x plus 1 to the -1 divided by -1 times the integral of the what's the differential of the inside? The differential is 3.
3, yes, sir.
So we're going to multiply it by a third. 1, 0. And then I'm going to stop right here because I know you have a class and I also have a class. So we're going to use that method. That method should work. That method look like it's working out because what I can do is factor out this 1/3 and just call this 4 pi over 3. And then now just go ahead with the or if I want, I can call this -4 pi over 3 and just use a 3x plus 1 to the -1 and just work it from there. So soon come right there. So all right. I'll be send it off to you so you can have a look at it and then you can work the second question. The second question that he placed in the chat. Let me just copy the second question now into the document.
So
Guys, please.
So I'll put the 135 degrees thing in it.
Yeah. I'm going to show you how the 135. Crap. Let me just go quickly and just see this. I knew I was supposed to do something. All right, so look at this one. Let's just go back to this one pretty quickly. Pretty quickly. And thanks for asking. This was a complete revolution, don't?
Yes, sir. 360.
360, right? So it means that I would have had 360 over 360. But what if it is? What if it is now that I'm doing? So 360 degrees over 360 degrees is going to be equal to 1.
Yeah.
Agreed? Good.
Yes, sir.
So when I did my integration, when I did my calculation, I did everything as 360 degrees. Then if I'm given 90 degrees, what if I'm doing 90 degrees? It will be 90 degrees of 360 degrees, don't it?
Yes, sir.
And that will be a quarter of a rotation. You follow that?
Yes, sir.
Good. So now if it is 135 degrees.
135 over 360.
Yeah, and what is that? What fraction that work out to? So it's going to, very good. So it's going to be 3/8 of your answer, which is why I said to you, let us work that afterwards. Because it's only going to be 3/8 of what it is that we're looking at. So it's really not a complete, it's not a complete revolution that we're looking at. We're looking at a fraction of a revolution. It's not in a quarter, it's not in a half of a revolution, sorry. It's not in a half, because a half of a revolution would be 180. So it's going to be 3/8 of that. So when I get my final answer and I times it by 3/8, it will tell me that the rotation is going to be at 135 degrees. Follow me?
Yes, sir.
So let me just recap that very quickly. So you may say to me then sir, why we did this one? You notice I put here complete revolution is 360?
Yes, sir.
I did that because it was 360 by 360. And when I divide 360 by 360, I'm going to get 1.
1. So if you multiply the answer by 1, you're going to get the same answer.
I'm going to get the same answer. So it never needed for me to go ahead and authenticate that it's going to be 360 by 360. No. But the mere fact that the man them said, no, yo, it's 135 degrees rotation. we have to go do the rotate, find a fraction of that rotation and show you what it is. All right. We'll
Okay.
continue this. I'll do this stuff. I can't promise you tonight because I'm going to have a 7 to 10. And I know when 10 o'clock come again, and I kind of sounding very nasal now. So when 10 o'clock come again, I want to drop asleep. So at some point in time tomorrow into Friday, I will do it and send you the stuff. But please, in the interim, I'm going to ask you to start preparing yourself for the mid-semester. We've gone through quite a bit of heavy calculations. Ready enough, getting ourselves ready enough for the mid-semester exam. So start putting things and working in earnest to prepare for your mid-semester, all right?
So when is that, sir?
We can talk about that on Monday, but it's very soon. It's fast
by
approaching.
next month.
By early.
Surprise me, sir.
No, I wouldn't do that. I've never done that. By early next month. But remember, we mid-semester, we have to arrange for coming, to come to the mid-semester. Because I now give the mid-semester online again, based on what I saw. So that's why I can't surprise you, because if I surprise you, you can't.
Face to face, mid-semester.
Say it again? Face-to-face mid-semester. Yeah.
What's the yeah.
Straight up. Big up on yourself, though. We'll talk here.
All right.
Cool.
All right.
Yes, sir.
Yeah, man.
That's Sean. Sir. Mr. Shan, sir.
Go on, I heard him.